Here's a tutorial for I stable, where I stands for initial, C stands for change, E stands for end. So here are some Kisses chocolates. If we have 3 chocolates and their wrappers, one wrapper will pair with one chocolate. The same applies for chemistry. In the reaction of sodium hydroxide and sulfuric acid, the molar ratio in the equation is 2:1. Remember in I stable, in order to compare the amount of chemicals, we use the unit mole. Let's say there are 50 grams of sodium hydroxide given to us. In the periodic table, each element that comprises of the compound have its own molar mass. The molar mass for sodium hydroxide is 39 grams per mole. After we find that, we do the math and find there is 1.282 moles of sodium hydroxide in 50 grams. Now we want it to be fully reacted. That is, we want to use all of the sodium hydroxide. Then how much grams of sulfuric acid should we use? Remember, every 2 moles of sodium hydroxide react fully with 1 mole of sulfuric acid. So there should be more than 1/2 of the moles of sodium hydroxide, which we found earlier is 1.282 moles. So we have to get more than 0.641 moles of sulfuric acid. Now we're clear about the molar ratio. The reaction will fully turn the reactants into products. The change would be 2x moles here for sodium hydroxide, because it has to be 2 as in its molar ratio, and 1 mole for sulfuric acid. For every 1 mole of 1x mole of sulfuric acid, there will be 2x moles of water produced, though here should be 1.282 moles of water. And there is x moles of sodium sulfate, which is 0.641 moles. The I stable gives us a clear visual of how many moles of reactants are being used and of products that are produced. The exact number can help us figure out how many grams we should measure out or get in our final product.